Types of motion. In this chapter, learning points are meaning of motion, importance of motion of objects, wave motion, classification of wave motion, important properties of wave motion, and simple harmonic motion. In this capsule, you are going to study about meaning of motion. Under this, you will also learn about perceptible and imperceptible motions. You will understand the importance of motion of objects. You will also learn about wave motion, that is, meaning and facts about wave motion. And under classification of waves, you will know about transverse and longitudinal waves. Hello everybody, watch this exciting video. How did you feel? What do you think is happening? You see that everything on earth is moving, isn't it? Now, look at these images. You feel as though they are not moving. But remember, Earth is moving, so they are also moving along with Earth. So, what do you think is motion? Motion is a natural event that involves a change in position or location of an object with time. We could say objects are moving because we were able to perceive them through our naked eyes. They are perceptible motions. For example, motion of a car. Motion of birds. Ball sliding down an inclined plane. Motion of a simple pendulum. Freely falling body. A stone tied to a thread and whirled. But we already know that atoms in matter are also in continuous motion or vibration. Such motions are imperceptible motion. Some more examples are: we have understood by theory that the Milky Way is moving at around 552 kilometers per second, but we are not able to perceive that. Similarly, continents were believed to be together and are moving away from each other at the slow speed of approximately 1.5 centimeter per year. This movement of continents is called continental drift. This we have understood by the theory of plate tectonics. Now, let us know the importance of motion. Why do you think that we have to study about motion? Well, study of motion of objects is an important aspect of physics. Most of the people use the knowledge of motion in their profession. Scientists are able to understand chemical reactions only because of movement and collision of particles. Geologists use physics of waves to study and measure the tectonic plate motion and predict volcano and earthquake. Cosmologists use study of motion to understand the behavior of heavenly body. Doctors use the know-how of motion to map the flow of blood to check whether arteries are blocked. This technique is called angiogram. There are many more fields of science which use the knowledge of motion. Now, it is time to think and answer. Which of the following is an example for imperceptible motion? Your options are A. Motion of a pendulum. Option B. Motion of a bird. Option C. Motion of a car. Or option D. Motion of particles in a solid. The answer is option D. Motion of particles in a solid. You have already learned about different types of motion like linear motion and circular motion. Have you ever thought how light from the sun travels to you? Or how are we able to hear sound? Yes, it is also through a kind of motion called wave motion. Let us understand more about waves. Hello children, let us do an activity. Take a tray filled with water. Allow it to stand for some time. Now, touch the surface of the water with a small stick or dip your finger. What do you see? You observe some pattern of movement on the surface of water. What can we call this pattern of movement on water? They are called ripples. You feel as though they are moving towards edges. Do they really move? Let us check. Place a leaf on the surface of water. Now observe carefully. Is the leaf moving towards the edge? No. It is only vibrating in its position. That is, it is only moving up and down. So, when we touch the water with a stick, the particles of the medium start vibrating about their equilibrium position. They will create a disturbance in the medium. This disturbance transferred from one end to the other end of the medium is a wave. This disturbance is transmitting energy and hence the leaf moves up and down. Remember, this vibratory motion of the particles of the medium occurs after regular interval of time and hence it is periodic motion. Let us define. Propagation of the periodic disturbance in the medium is called wave motion. Copy this definition. Now, it is time to think and answer. Does the particle of the medium in which a wave travels moves along with the wave? Explain with an example. The answer is Particles of the medium do not travel with the wave. This is shown by a simple experiment. Take a tray filled with water and a floating body in it. Allow the water to become still. Now, disturb the water surface with a finger. We observe that the ripples move to the edges of the tray and the floating body vibrates up and down in its mean position. This shows that particles of the medium do not travel with the wave. Now, let us know the important facts about wave motion. Wave is produced by the periodic disturbance at a point in a medium. During wave propagation, particles of the medium vibrate about their mean position. Only energy is transferred without the transfer of the particles of the medium. The speed of the wave depends on the nature of the medium and not the energy content. It's time to think and answer. The wave carries dash. Your options are option A, power, option B, energy, option C, displacement, and option D, work. The answer is energy. The wave carries energy. Your next question is, waves are produced by dash. The answer is, waves are produced by disturbance. Your third question is, the speed of the wave depends on dash. The answer is, the speed of the wave depends on nature of the medium. Your next question is, what is wave motion? Answer, propagation of the periodic disturbance in the medium is called wave motion. Now, let us understand the classification of waves. Waves can be broadly classified into two types. One, on the basis of direction of particle vibration and the direction of wave motion. The other is based on the medium of vibration. First category includes vibration of particles along the direction of wave motion, that is longitudinal wave, and vibration of particles perpendicular to the direction of wave motion, that is transverse wave. Second category includes matter and field. Under matter, we have mechanical waves, and under field, we have electromagnetic waves. Copy this. Firstly, let us understand about mechanical waves. The waves which need a material medium for their propagation are called mechanical waves. Remember that the medium is simply the material through which the disturbance is moving. We see mechanical waves very often. Water waves. For these waves, water is the medium. Seismic waves require earth as the medium. Sound waves which require air. Further, mechanical waves are broadly classified into transverse waves and longitudinal waves. Now, observe this animation. Here, the particles of the medium are vibrating perpendicularly to the direction of wave motion. Observe the red particle carefully. This is transverse wave. Now, observe this animation. Here, the particles are vibrating parallel to the direction of wave motion and it is longitudinal wave. Now, think and answer. Observe this animation of the waves on water surface. What type of waves are water waves? Answer: they are transverse waves. Now, observe the second animation. What type of waves are these? Why? Answer: they are longitudinal waves because the particles of the medium vibrate parallel to the direction of wave motion. Here is an interesting fact. Do you know, if light radiations were mechanical waves, then we would not have received solar energy. This is because the space between sun and the earth is vacuum and mechanical waves do not travel through vacuum. Fortunately, light can travel through space and it is an electromagnetic wave. These type of waves are field waves and require no material for their propagation. They include ultraviolet light, radio waves, X-rays, etc. Let us understand in detail about transverse waves. Observe this figure. You can see the position of particles in the medium when there is no disturbance in the medium. Suppose there is a disturbance set up in the medium. We can represent it like this. During propagation of the wave, the particles in the medium vibrate perpendicularly in their position. Now, the elevated portion of the wave is the crest and the depressed portion is the trough. One crest and one trough constitute a wave. Observe this animation. Do you feel it is different from transverse waves? Yes, the particles vibrate parallel to the direction of wave motion. You observe that in some places the particles are closer. That is called compression. And in some places the particles are further apart. It is called rarefaction. So, longitudinal wave consists of compressions and rarefactions. One compression and one rarefaction constitute a wave. Examples of longitudinal waves are sound waves, ultrasound, oscillations in a spring, vibration in gases, etc. Here is a video on internal water waves. Now think and answer. Which of the following is a longitudinal wave? Your options are option A, radio wave, Option B, X-rays. Option C, light waves. And option D, sound waves. The answer is option D, sound waves. Here are some questions for you. Discuss with your friends and answer. First one, the source of all wave motion is a option A, wave pattern, option B, harmonic object, option C, vibrating object, or option D, region of high and low pressure. Note this down. Second question, the vibration of a transverse wave motion is in the direction dash. Option A, along the direction of wave motion, or option B, at right angles to the direction of wave motion. Note this down. Your third question, which of the following waves cannot travel through a vacuum? Option A, sound waves. Option A, sound waves. Option B, radio waves. Option C, light waves. Or option D, X-rays. Note this down. Your fourth question, what is the nature of waves produced if a spring is compressed as shown in the image below? Your fifth question, one end of a rope is tied to a fixed support. The other end is moved up and down to create a crest and a trough. What would be the nature of wave produced by this? Note this down. You have understood about meaning of motion. It is a natural event that involves a change in position or location of an object with time. Types of motion. They are perceptible motions which can be perceived through naked eyes, and imperceptible motions that are those which cannot be perceived through naked eyes. Study of motion is a very important aspect of physics. In chemical reactions, for geologists, for cosmologists, for doctors, and many other fields. You also studied about mechanical waves, waves that require material medium. Types of mechanical waves are transverse waves in which particles of the medium vibrate perpendicularly to the direction of wave motion, and longitudinal waves are those in which particles of the medium vibrate parallel to the direction of wave motion. In this capsule, the keywords are perceptible, imperceptible, wave, transverse, longitudinal, perpendicular, parallel, crest, trough, compression, and rarefaction.